Welcome to another CO2 Monday with Trevor. I'm your host, Trevor Matthews, and today I got a special guest, a good friend of mine, Nigel Birkett from a company called Gateway Mechanical. Me and Nigel go back many, many years. He actually was one of my second foreman in the supermarket industry, and I think I was a second year, and you were a third year, Nigel. I think Nigel was
Sounds about right.
running jobs forever. And today we're going to be diving into the do's and don'ts of installing and commissioning of CO2 transcritical systems. And Nigel's been in the industry for a long time, working with CO2, lots of different trainings. Nigel, welcome to CO2 Mondays with Trevor. How you doing?
Good, thanks. Good to be here.
Awesome. Nigel, why don't you give a little brief introduction of yourself and a little bit of your experience for everyone?
Well, I've been doing this for over 20 years now. I got started, wasn't actually signed up as an apprentice until 2000, but I was actually doing work in the industry for a couple of years before that. It just had to get my foot in the door. Did HVAC, predominantly HVAC for about 5 years, and then started to get into the supermarket and the commercial refrigeration. And I have no problem with HVAC. I just find it gets a bit monotonous after a while. So the supermarkets have been, good good way to keep me entertained and intrigued in the industry. And now, just like I said, from that, just going on to CO2, the next latest and greatest thing. It's if you haven't had a chance to work on it, do it, because it's a lot of fun.
Awesome. When was the first time you seen CO2? Like, was it a cascade system, secondary system?
It was a secondary coolant was the first one I worked on, where essentially, you're just using the refrigerated CO2, pumping it as a liquid, and it comes back as a liquid. It's just because you can get the low temperatures without having to worry about your fluid freezing. So it was CO2, but it wasn't DX, direct expansion CO2. So that's where it gets really fun.
Yeah, yeah. So I know you've been in a few trainings when I used to work at Emerson. You flew out with a team of you, and we did some trainings. Talk about some of your experience with CO2. So you did that secondary pump system. So when was the first time you seen a transcritical booster system?
I want to say that would be about not quite 10 years ago, probably 7 or 8 years ago.
Mm.
And it was still fairly new to Canada, let alone Western Canada. All of our racks and equipment were coming from basically Montreal. So they had a few years on us as far as getting the bugs worked out. So it was very much the first couple of years here in Calgary, especially, was a crash course, kind of figuring out. Like I said, there was plenty of people with information. It's just they were somewhat selective as to who they shared it with. So we were kind of blind leading the blind as far as the first few years, but it's really come along. And I can only see more growth and potential for it in the industry.
Yeah. Yeah, no, I've definitely seen a lot of that too, and I continue to see growth. And this is why I do this. This is why I do CO2 Mondays, because I know CO2 is going to be mainstream. It's going to be the main commercial refrigerant out there, and we want to get more knowledge out there. So let's get into it. So I was talking with Nigel, and he's recently did a few installation jobs, and I really want to find out, since he's been so close to it and it's been so recent in his mind, I wanted to talk about some of the things that he saw running. Was this one of your first stores that you ran, or have you run other CO2 installation projects?
Actually, I wasn't running this most recent one.
Okay.
I got the real cushy task of doing the startup and commissioning. So all the real hard work was already done by the guys, and they just knocked it out of the park. So they kept my job real easy. But essentially, it's not a lot of, until you actually do the startup. It's very similar to a standard supermarket installation. Typically, your line sizes are smaller, quite a bit smaller. Copper is a little bit heavier. You're using type L copper, type K. I can't remember, whichever one's the thicker pipe. But yeah, like I said, you're not running those crazy 2 1/8 or 2 5 suction lines. It's typically 1 1 with CO2 has got so much capacity. It's but other than that, like I said, hangers wise, it's very similar. It can be kind of intimidating at first, but really once you start working on it, it's just like working on HFCs, except you got to be aware the pressures are higher. But I just love working on it so much.
Yeah.
Uh,
But let's talk about the process. So you went into this job and your team was already working on it. I guess they were doing all the piping, they were doing all the evacuation, they were doing all the setup before you got in there for the startup and commissioning. Why don't we go through what their process was before you get in there? Because I know you were mentioning the team crushed it. They did an amazing job. You were telling me everything to spec, purging and everything. What was their process before you got there?
um, Crossing the T's and dotting the I's.
Mm,
Everything was secure and strapped. There was very few odds and ends that had to be done. They were very, very diligent with when they were doing their overheads and their brazing that they had. They were purging with nitro on everything, and everything got a good scrubbing and blasting out with nitro. So again, from a startup perspective, that made everything in a lot smoother. Going back not quite 10 years when we did those first stores, barely purged with nitro. I think we charged the racks with industrial grade CO2 as opposed to the refrigerant grade. At the time, it was kind of nobody really figured it would have mattered. I think the industrial grade is 99.5% pure and the refrigerant grade is 99.8% pure. But it turns out that 0.3% is just little tiny particles that love to plug filters and contaminate oil. So like I said, most of our hangups on this startup were due to our equipment manufacturers not being ready. They were behind the eight ball pretty much the whole job, and that really is what hurt or hindered our startup, I guess. But as far as like the installation, like I said, again, it is not really any different. It's doing all the right piping practices and verifying lines. You don't want to have a cross suction and liquid, especially when you're running, for example, 3/8 and 3/8, right?
yeah.
You just got to be diligent with your piping, and every single case is its own circuit. So that means you have 60 or 70 cases that you have to verify the suction lines aren't crossed. But
Yeah.
once if you verify that, then you're off to the races, right? So
Yeah. One thing I love about doing these CO2 Monday podcasts is that we get live questions, and we got a question here I'm going to throw at you from David. Do you use Silfloss or silver solder for brazing?
we use Silfos, except for obviously brass joints or there was our connections at basically the flex pack where it tied into our gas cooler. That connection there, we actually use silver solder. It it held the
Yeah.
1800 and whatever 50 psi on pressure tests. So, but all the standard joints, yeah, it was just regular Silfos.
Okay. And so you had a good point there. So did you pressure or test the whole high side at 1850 psi or 1900 psi or?
We basically did just our gas cooler. The the equipment from the manufacturer is tagged that they've pressurized all of the pack piping to 10% above the rating. So again, you have different pressurized different reliefs. So they've pressurized each individual section up to the pressure codes. So all we had to do was all of our piping that wasn't already connected. So that was basically the gas cooler and then the gas cooler piping, which we did to our reg kind of topped out. We didn't get it quite as high as we wanted to, 1850. But then like I said, we did the store pressure tests to, I want to say 800. Again, just it's all based on you don't need to pressurize your it would be unsafe to pressurize your low side to
Mhm.
your transcritical pressure. Obviously, it's not needed. So
Yeah. Yeah, and isolate, and this is one of the big things, and I've talked to many manufacturers about. You want to isolate those certain components that are that max out. Just say if it only goes to 650, but the pipe needs to be pressure tested maybe to 800, you would
oh yes,
isolate that
absolutely.
section, and then make sure that because you could damage those components. And I
Oh
know,
yeah, and you don't want to be popping reliefs just with nitro.
mm,
They should reset, but or reseat, I should say, sorry. But how many times is that relief valve going to reseat? You don't need to be popping it 5 times before you've even started up your rack. So yes, they do have isolation, and that is part of the connected component. That would have been part from the equipment manufacturer, that they would have isolated and pressurized their piping. And then yes, like I said, we when we did our pressure tests on our cases and then our gas cooler piping, we had the pack isolated so that we weren't, obviously we didn't want to have to disconnect all our reliefs again.
yeah. And I'd like to get back to something you said earlier. We might as well just jump into it. You said a few of the hangups, and I've been hearing this from more and more refrigeration professionals, technicians out there on startups and installs, is that they're running into manufacturer issues. Maybe it's the supply chain, maybe they can't get to the certain parts. How did you overcome that? What were some of the issues, if you can talk about it, and how did you overcome some of those problems to make sure that that end user at the end of the day, because you're working for the end user, you need to get those guys up and running. What are some of the things that you were able to do and overcome?
It's funny story. The end user was quite unhappy with the equipment manufacturer. We ran into all sorts of problems.
Mm,
The one unit, the phase monitor, the wiring was there. Like the phase monitor had been there, they wired it, but then the phase monitor was removed, and there was a piece of tape saying essentially IOU one phase monitor.
yeah.
Right. Well, that's one thing when it's in the factory, on the factory floor, that you put a piece of tape to remember. But when it gets all the way on site and I'm in a somewhat remote location and I've got a unit that doesn't have a phase monitor, that's no good, right? So a lot of stuff like that slipped through the cracks, and it felt it was rushed. So the
Hmm.
entire job, they about halfway through the job, the end user decided to go with a different engineering company. I
Mm,
don't know what the motivation behind that was. Um, and so a large portion of the job was actually installed without engineering. Um, so then that caused a whole other bunch of headaches. And then the engineers who ended up supplying us with a lot of our details for our equipment, they didn't really know. I'm not sure what information they were trying to work off of, because they had a lot of like I said, that the check valve on the gas cooler that they said was a necessary component, and then we were looking at it saying, this is not only is it not necessary, it's actually a safety concern to leave this installed, right? So I
so
think it
why
was
would
just,
that be a safety concern? What would happen if you
well,
had that check?
basically in the event of an emergency, there's a check valve that they put in the drop leg from the gas cooler.
Mm,
If you were not in transcritical and your gas cooler was actually working like a condenser and you had liquid leaving and going back to your rack, if there was ever a power outage, the magic valve, the ICMTS, will slam shut, and you will
mm.
actually close off your liquid return line. And now if you have a check valve in that line, liquid compression, hydraulic compression,
So you could trap the liquid
trap
on,
the liquid, and
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 and that's something
therefore
you do
create.
not want. You never want to
Exactly.
trap liquid CO2 because it expands. It's 10 to 1. I think it's, what was it? So every 1 degree Celsius is 10 bar.
Mhm.
So, 1.8 Fahrenheit is 145 PSI, somewhere's around that rate. So that's astronomical. So you never ever want to trap CO2 liquid. So let's get back to missing the phase monitor. And this happens on a lot of jobs. I've talked to a lot of technicians out there, and it's not only with CO2 equipment, it's with other equipment as well. What are some of the things that you guys did as, refrigeration professionals to overcome some of this and to meet the challenges? Because that's a big thing as a refrigeration professionals. We can't get all caught up and blaming everybody, you know what I mean? Because I know that's not the way it is. We need to fix the problem and go on. So what are some of the things that you did? And did you work with the manufacturers, the engineers with that to get the ball rolling?
We did as best as we could. Like I said, from their standpoint, the check valve is installed, and they have pictures of the check valve. From what we know, we ended up taking the check valve. We did the pressure test, then we took the check valve apart and we took the flapper out of it. So essentially, that check valve is just a big fancy coupling. But from the engineer standpoint, they've checked all the boxes on their end. The check valve's installed, and from our standpoint, we've disabled it. So, and again, it served no purpose anyway, functionally. It was more of a, I think the engineer thought he was actually designing an HFC system with a split condenser, where you would have your check valve in your split side. And that's the only thing I could think of why he would have this check valve. In CO2, you don't really have an off cycle. You don't want your medium temps to stop running. There is no, a situation where the rack would shut off and you'd have to worry about refrigerant migrating. So it was really a superfluous part, and it had the potential to create a very big safety concern. So, we had to use a lot of common sense, and you couldn't take anything for granted. All of the suction dryer cores, they were tagged as filters were installed. And we ended up pulling them out, and sure enough, the cardboard sleeves were still installed. And, it's just, if we had just missed one of those, and then, we would have been picking cardboard out of screens for, a year to come, right? Yeah. So, it really just came down to, I hate to use the term common sense, but it's, you just kind of have to pool all the stuff you've seen in the past, and you can't take anything for granted. You just got to assume everything is wrong, and you have to prove that it's right. Don't go the other way around. Assume it's right, and then find out it's wrong. Yeah, definitely.
And so with the thing with that, for example, with that check valve, is that something you would have talked about with the manufacturer? Because you're talking about the engineer there. Did you talk with the manufacturer about that particular issue you were talking about a minute ago? And
so the engineer was employed by the equipment manufacturer. However, the guys they sent out, this is also from the equipment manufacturer, their mechanics came out and they were saying same thing as us, like, what is this for? This is dangerous. So it was actually we had discussed it with their, I guess technically their service guys, that we were going to disable the check valve. So we kind of had approval from the manufacturer, but
yeah,
again, the guy who designed it probably didn't know what he was designing anyway. So to ask for his opinion, like I said, from their standpoint, paperwork wise, everything's done and it's safe. So
now that you got the pressure test done, you did a proper evacuation, because that's really important in any system. Proper evacuation, proper pressure test, no leaks. Because I've been hearing more and more about CO2 systems are getting installed way better than any HFC system that most people have done, because they're spending the time, it's new to them, and they're doing it the way you're supposed to be doing it. Not like the way I did it 18 years ago, just trying to figure it out along the way. So what's the next step that you've seen there after you get up to this point, you get the equipment up and running?
Well, again, you got to make sure CO2 is a different animal. There is no starting up, or just going to throw a few bottles of gas in there and then we'll shut it down and we'll come back tomorrow and we'll finish. The CO2, you especially with the transcritical, you have to have your medium temp running first. You have to have enough load that's going to keep your medium temp compressors running, and then you can start bringing on your low temp. Just again, I don't know if you've gone over the piping with everyone or.
No, why don't you talk about it?
Well, it just, essentially your low temp compressors discharge into the suction of your medium temp or your transcritical. So you can't have low temp running without medium temp, and the loads kind of have to be balanced. But when the rack's on, it's on. There is no pumping it down and coming back tomorrow to make sure it's running right. You have to be committed. When you do your startup, you're turning it on and it's going to stay on. If it goes down, it's not the end of the world, but you might vent and lose a bunch of your charge. So it really was, like I said, the program. I've never done I've always done microthermal with CO2. It's a very good system for CO2. There's lots of information. This most recent one was actually using E2s, so CPC as the controller. It's still adequate. Like, it still manages all the information. It's a little bit underpowered. The E2, just for processing power, it actually had to have 2 E2 units installed per rack, and the second E2 was just a slave. It had nothing programmed, no information on it. It was just using that second E2 to increase its processing power, which I wasn't a big fan of. I kind of feel like if the single controller isn't strong enough on its own to handle it, you should maybe look at a different control system. And compared to microthermal, it's very clunky, navigating back and forth. But again, it's like anything. Once you get the hang of it, it gets easier. So again, verifying before you actually put any gas in, you've got to, like I said, we did our pressure tests, we did our vacuum test with overnight decay tests. Then you turn on the controls, and you got to do just a barrage, about 6 hours worth of testing on the control system before again, you don't want to be caught off guard when you're going to do the startup. You want to be, anticipate potential issues and make sure you've dealt with as many of them as you can beforehand. And then, like I said, it'll make it, if you don't, you're going to find out about anything you missed anyway. And it can be a much bigger pain in the butt with CO2, just because you have to keep it running. You can't just, we'll just pump this down and do this. There's steps you have to follow once it's running. So to not have to backtrack is definitely save yourself some time and a few 100 pounds of gas.
Yeah. So I see more and more systems are having multiple systems on it. It seems like we're going to more a distribution network instead of just having one big mechanical room. We're having multiple systems, multiple, I guess they're kind of like porter packs or protocols or iPacks or whatever you want to call the HFC ones, going to these more individual units. So after you got one started up, what's your process? So you did the proper evacuation, pressure test evacuation. You went through all the parameters. That's a big one, going through all those set points. It's a tedious job, but it's one of the most important. It's kind of like I tell people, testing every screw, tightening every screw on a rack. That was one of the things that
it's a pain in the butt. But if you have one wire jiggle loose from a contactor, you could be looking at a $10,000 repair to take the extra 45 minutes and it's same exact thing. You just have to, your eyes will start to cross, and your legs get really tired because you're just standing in one spot for half a day. But
so you went through all that setup. You went through and you made sure and you verified that all the points were set up. What was your next steps after that?
I guess basically we would have been startup. Essentially, you want to charge your whole system with vapor. Everyone knows why. Obviously, I think at this stage, CO2 can be tricky. You don't want to create dry ice in your lines. So, what is it? 107. I think
What did you guys put in there? How much vapor did you put in? Do you remember?
2 bottles. We brought everything up to over 150 psi.
Okay.
Again, I think I can't remember all the actual numbers. 100 and
that's okay. It's 61 or 61 psi or 74 psi.
Yeah, anyway,
you get it up to 100,
150, and then then you're ready to start really going. It's basically you want to make sure you don't overload the rack. You want to start up one system at a time, just trying to get gas in, while you're running. Basically we had our variable speed medium temp compressor running at 50%, and we just had it locked on at 50, and just keeping an eye on your suction pressures. Don't want to let it get too low. When you're first starting to charge, getting too high usually isn't a problem. But we had I would say at least 2/3 of our medium temp circuits up and running. And we were probably over 50% charged with our final charge with liquid before we even brought on our low temps. And like I said, the rack really kind of tells you when it's ready. Your suction pressure will go, your tank, your receiver, your pressure will rise, and as it does, it'll start to open the bypass, which allows pressure to your low temp suction header. And then, you know, like I said, as you're bringing on load and the pressure in your tank rises, your bypass valve starts to open, and that's you know, then your suction pressure starts to come up. And then as your suction pressure comes up, obviously that's time to bring on a low temp compressor. And again, use the variable speed right off the bat, just so that it's actually a digital, not a variable speed, sorry. And you run it at whatever 15% capacity for the first hour until you get enough. Again, it's just a matter of, you know, by the time you have one or two low temp systems running, you should have all or most of your medium temp load on. And again, it just, you kind of have to go slow and steady. You can't overload it, because you will, if you try to turn everything on at once, it'll just bring too much load back, and the compressors just can't handle it. Your gas cooler, you'll trip on high discharge, right? So, and that is part of the program with the safety shutdown. In the event of a power outage or any kind of control failure, it has a staged startup. So, kind of frustrating for service, especially if you're not aware of it, because you'll be sitting there going, why the heck are all these valves off? Why, you know, why is everything offline? It's because of that. It only allows you know, one medium temp system, and then it has to verify that that pressure has started to drop before it'll allow the next available circuit to come online. So it's all, you know, if you want to get really deep into it, it's all about, you know, flexible combiners and just making sure certain parameters are met before it allows the rack to go on to the next stage of startup.
Is this something that you would have designed, your company, or does this come from the manufacturer?
This came from the manufacturer. It was, again, a little confusing, but you can follow through if you know E2s fairly well. It's with all things E2, they're kind of simple and complex at the same time. It's just it's like a bunch of simple functions all combined together to make it complex, right? So yeah, you could kind of follow the thought process. This had to be, you know, this valve had to be verified, and you have to have superheat above 30 degrees before, you know, there's a bunch of different factors that have to be met before it goes to the next stage. Just again, the particular setup we had, there was no backup. So stores I've done in the past, you've got either a condensing unit that runs off of a generator, and it has a heat exchanger to cool the tank. Or I've seen another scenario where you have a really big generator, which is designed to run one or two of the transcritical compressors, again, to keep the pressure in that tank down. This site has no backup. So there's a small UPS inside the unit. If there's a power outage, it forces the ICMTS and your suction bypass valves closed. That's it. If the power goes out, the tank shuts, and essentially if it does vent, you'll only lose what's in your tank. I guess actually it would still be connected to your suction lines, but it's designed to minimize the amount of gas you're going to lose, but it's not a very good system. Basically, if there's a power outage, any kind of control issue, the rack's going down and you're probably going to lose a bunch of gas, right?
Yeah. Yeah, and I've heard about this, and I've heard this for many, many years with CO2. What a lot of store owners do is they'll keep a whole charge on site just in case of anything like that happens. And I'm not sure if it's the cost related to it. It's cheaper to have a whole charge on the site in case power goes out and you lose it, or you know, because I'm hearing more and more, and I've talked to a lot of technicians out there, refrigeration professionals out there, saying that they don't have backup systems. Most of their sites don't have backup systems in case the power goes out. Because in the middle of the winter, probably not so bad here in Canada. But if you're in Phoenix or something and it's 110 degrees outside, you know, or 40 degrees Celsius outside, you're probably not going to last too long without blowing the reliefs.
Oh yeah, and and they're designed so that they vent vapor off the top of the tank, which cools the remaining liquid. So it's you don't see that with HFCs. You don't just we don't just vent part of the charge to keep the pressure down. And so the fact is, if you get there after a power outage, usually you can just start it back up and off it goes. With the CO2, you have to be aware if it was off for 6 hours, I don't know how much of my charge is actually left in the system. So, there's a good chance you're going to want to get your charging hose ready and get some bottles. Ideally, sites that don't have a backup, yes, they would have a holding charge. Most of our sites have backup and a holding charge on site. This particular customer, no backup, and there's no allowance for spare gas to be left on site. And we tried to change their opinion on that. We're still trying to. There's another store in Toronto or in Ontario somewhere where they have same exact scenario, same exact setup, and they've been fighting to try to get gas storage allowed on site. And this has been ongoing for a few months, and they still haven't got the approval. Now, that being said, it was only about a week or two ago, they had a big issue at that store and they lost their charge and they didn't have backup gas. So they ended up, the rack was down for a considerable amount of time. It resulted in product loss. Since then, they are reviewing the decision as to whether or not we can keep gas on site, which it seems ridiculous to me not to be allowed, especially these newer installations. For example, the big, single rack units, transcritical, we were putting in, I want to say about 3,000 pounds of CO2. Whereas these smaller packaged installation units, one unit is between 700 and 800 pounds, and the other one is 600 pounds of gas. So to have a holding charge for one of those units, you're only talking about 10 or 12 bottles of gas. It's basically one pallet of CO2. And you think about an entire grocery store, you should be able to find room for a single pallet somewhere. But you talk about what have you got to lose? It's a lot, right? If your low temp rack goes down, what do you stand to lose? It's a lot. As opposed to just keeping a pallet of gas nearby, right?
Yeah, and I've heard this. It's at the end of the day, it's the store owner's decision usually on that front. So nothing that us as refrigeration professionals can change, but we can influence and just recommend. So after you get that one unit started up, there's a process you talked about where if the power goes out, there's a staging back up. So you stage so many percentage on different criteria to start ramping up the compressors and turning them on, because you don't, like you said, you don't want to overload the system. So you tested all this. How did you test this stuff? Like, is there did you do it step by step? Do you have a checklist when you're doing a startup? Like, what is your process when you're doing this startup to make sure that you go through and you check everything off? Or does the manufacturer offer one? Sorry.
They did. It was it was detailed and vague at the same time. And they say you have to check everything. The tricky part, the hardest part by far, was none of the sequence will actually start to kick in. One of the very first parts of the sequence is the compressor proofs. Okay, so if your compressors aren't running, it's not going to start trying to allow anything else to open, right? So when we were still on pressure test or evacuation, we were trying to test these controls. And so it's tricky because you have to bypass or override in order to test the controls that are downstream, because the first step is the compressors have to be running and proved to be running. Well, we can't run them when there's only nitrogen in the system, so you have to override that proof. And then
do you want to explain to everyone what the proof is, just an explanation?
Essentially, proof of running. So it's saying that the compressor should be on. Then there should be current sensing relay verifying that the compressor is on, and that works both ways. If the compressor is running and it's not supposed to be, that would be a proof alarm as well. But essentially, it's looking for the compressor to be on before it'll allow you to move forward with any of the other stages. And we can't turn compressors on. So anytime you have to override something in order. I don't like it because it doesn't feel like a proper test, right? You can't say I tested or I set my low pressure switch if you had a jumper on it and say, well, I adjusted the spring, so it should be good. You have to actually physically test it. So it was difficult in that standpoint to test everything beforehand. But then we were able to, once we had it running, basically we had to test steps 3 through 12. And then once everything was running, then go back and test steps 1 through 3, right? So, a little backwards, but it works. It's again, it's just going through and being meticulous, right? And checking every screen and checking, and then making sure it works beforehand. You can't get impatient. Well, you can, it might save you a little bit of time, or it could cost you a lot of time later, right?
Yeah, and especially like the more and more professional I talk to who are installing CO2 systems, they're taking their time. And I know you're under the gun a lot of the times, and everybody wants their store up. I've been there. You got 12 hours to install 60 feet of cases. You know what I mean? It's just almost an impossible task. So it's no different here. But you want to take a breather, understand what you need to do, and just start working towards that. I got a question in the chat. Can you go over setting up gas cooler valve and the bypass valve? Did you set those up, or was that already pre-programmed from the manufacturer?
Those were pre-programmed from the manufacturer. They're fairly generic. So again, it's I'm trying to think of what variables it's actually looking. Your ICMTS is your valve that's allowing gas or liquid from your gas cooler into the tank. And then your bypass is what is basically vapor bleeding off the top of the tank going to your low temp suction. So it's actually doing a calculation based on your if you're in transcritical, that's the only time those valves actually start to modulate to actually get liquid from the tank. Of course, if you're in transcritical, your gas cooler is just rejecting as much heat as possible. You still have vapor coming back to your tank, and then you're actually, as you're pulling vapor off of that tank, you're refrigerating your refrigerant essentially. That's why your efficiency goes down when you're in transcritical. But I guess I'm really beating around the bush trying to figure out how to actually set it.
Did you check the set points? Because a lot of
we
times
did. I verified, and I'm trying to remember offhand what they were. If you go to the Danfoss ICMTS and then the EKC88, I believe, the controller, they are fairly generic for CO2. It's going to be based on your ambience, your climate of where your installation is, right? Your best bet is going to be just check with Danfoss and see what they recommend.
Because if you're above the Nigel, if you're above the transcritical point, which is 87.8, 31 degrees Celsius, there will be probably a differential of a couple degrees in there where it'll push it into transcritical. And at that point, you should be maintaining some sort of pressure. Yeah. You're in the gas cooler. So not sure exactly what your pressure would be set for, but when you're below that and you're in subcritical, you should be monitoring subcooling. And I don't know exactly, depending on the manufacturer, because now you have liquid coming down that drop leg of that from that gas cooler condenser.
Yeah, and it does change depending on if you're in subcritical and transcritical. Again, like I said, I would definitely just check. Don't take my words verbatim as to what to set it at, because it's going to be different for every application.
Exactly.
And Danfoss they make a hell of a product, and they're pretty helpful.
Yeah, they are. Definitely lots of great information there. So we went through, the kind of the startup and the procedure if you have a power outage. Now you're running a system, you got it up and running. What is your next steps that you and your team do to verify? Because you went through this checklist, we'll say, where you checked all the pressure transducers, the temperature probes, you went through the high pressure valve, you made sure things turned off and on when you had alarms to make sure all the alarms work, because that's a big one, right? You need to make sure every
Mhm.
alarm works. And this is no different than any other install. Like this is what you got to do on standard systems, but it just gets, I think it's more fine details with CO2 systems compared to synthetic
There,
membranes.
like I said, you have a few extra components, right? You have an oil transfer solenoid. So you have an oil separator and then an oil reservoir. And so whenever your oil separator fills above a certain point, it'll energize a solenoid to transfer the oil from the separator to the reservoir, right? So you do have, you know, you wouldn't see that on an H, or I have seen, I think, one application where I've seen it, but it's not typical to see it on a, you know, an HFC rack. So there is a lot more data points. And so there's a few extra components on the rack. And really all it is there's a lot of data. Every single evaporator has to have, every single valve, expansion valve has its own case controller. And, you know, so if you've got 150 cases, you've got 150 case controllers. A lot of information, but at the same time, you get to leave your tools in your truck.
Yeah.
You know, temperature probes, you've got each individual case, you've got a discharge air sensor, you've got a coil sensor at the outlet, at the inlet, you've got a suction transducer, and sometimes you'll have even a termination sensor. And then, you know, like that's a lot of data points just for one case. And if you don't trust any of those, you think one of them's out, you just look at the case right beside it. You know, it's gonna be the same or pretty close to the same. It should be within 1 or 2 psi. You know, like I said, there's a lot of information there, and you can really start to use that information for service, just because you have so much log data that there's, you know, so many data points to look at. But
Whose case controllers and valves were in that for this example?
what's that?
Whose case controller
It was
and
CPC. So they were Dixel.
Excel?
And then they were just communicating on the Modbus. That was the only thing that was frustrating with those, is the way the lighting circuit works. All the lighting was controlled through the individual case controller, and then it ran just like you normally would on a lighting schedule. But the problem was when the rack goes into shutdown, it shuts off all of your case controllers.
Mm.
So when we went in, and we were doing this a day before grand opening, and we were trying to do our oil filters on the rack, and so we put, you know, we did our pump downs, and it took about an hour and a half to shut the rack down, do our oil filter, and do both of our suction filters. Within 2 minutes of us shutting the rack off, we hadn't even, we just started pumping it down. So we hadn't even fully shut the medium temps off. The low temps pumped down and they went into a proof failure. So all of the low temp circuits, all the case controllers shut off, and all of the case lights shut off. And then about a minute later, we pumped down, we had the whole rack pumped down. So then that shut off, and then all the medium temp case controllers shut off. So all the medium temp cases shut off. The lighting, anyway. So this became a problem because minutes of trying to pump down the rack, we had customers calling us, saying, you know, this is shut down and this is, so there is no, you know, sometimes you just go into a store and you say, you know, you can, yeah, we're just doing some work on the rack, you know, you can go and disable the main alarm for an hour and do your pump down, and everybody, nobody's, you know, none the wiser, right?
Yeah.
With this store, they know the second you start working on anything, the lights shut off. So, you know, there is no, they're aware of it immediately. As soon as, you know, the case hasn't even warmed up yet, but they're aware that the refrigeration is off because the lights are off, right?
Yeah, yeah.
So that made it a real, you know, trick to service.
So I'm assuming they would have been like either CC200s or XM678s or
XM67, yeah.
And then would you have Danfoss valves in there with those, or what valves?
No, they were pulse Sporlan. So they
ones?
were pulse solenoids. And this is the first time I've ever actually used those in any kind of capacity. And they are just solid, like rock solid. I walked down an entire 110-foot lineup of glass doors, and we had all the case controllers pulled out because the store wasn't open yet. And it was just -7, -7, -7, -7, -7, the entire way down. They were just rock solid. The only thing that was a bit of is the clicking. When you stand in the one deli department and you're surrounded by produce, deli, and there's 120 valves all in your kind of immediate vicinity, and they're all click 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 clicking on and off. It's a minor thing. It's the type of thing that probably only a Friggy would hear, but it was a
Yeah.
little annoying to me. But other than that, like I said, control wise, they are really, really effective.
Yeah, I was listening to a podcast this morning on the at the gym. Listened to a Dan Foss podcast talking about, I think it was David. He starts with a Y. I can't remember, and Chris something. I can't remember their names. I'm gonna reach out to these guys, but they were talking about these pulse width modulation valves and the AKs, which the AK valves tends been out for like over 20 years, and the same thing, pulse width modulation. And then they did a redesign in 2018, I believe, to reduce that the ticking sound. But when the store first starts up, this is exactly what they say. There's nothing, no product, there's no people, there's no babies crying.
Mhm.
So you can hear the ticking, but usually it's just
Once the store was open, it was a lot less noticeable. When we had a bunch of the pans out of the way and everything, and it was
yeah,
like
what's
click
going
click
on?
click click click. You'd go to bed at night, and all you could hear was clicking. Yeah.
Yeah. Okay. Yeah. So that's good. No, I hear they're pretty solid. So I've talked to many different refrigeration professionals. Some people do not like pulse width modulation valve. They like steppers, and vice versa. Guys like pulse width modulations because there's differences between them. And once again, head to that Dan Foss podcast and check out their It's Cooling Conversations, I believe it is, and check their pulse width modulation one, and they'll talk about the advantages over stepper. Because I'm a stepper. I like stepper motor valves, electronic valves. But there are some advantages, and one of the ones that I took away from that one on the pulse width modulation valve, they said, is that every time it closes and then opens up, it has a bit more force going in there, so it feeds the evaporator a bit more, so there's a bit more heat transfer, which I thought was
Okay.
really interesting for the pulse width modulation valve. So I'm going to look into that a bit more.
I was also curious about the oil return, just because you're not metering or trickling this refrigerant through it. It's full force each time it pulses on. I would like to do more. Like I said, his store was fairly recent, so that's all part of running it for a year and seeing what kind of oil issues, or if there are oil issues or not, right?
Yeah, no, and this is what one great thing, we're continually learning, especially with
Mhm.
this, and this is what I love about CO2, because I talk to people that are in Europe and been doing it for 10, 20 years, and they're still learning. And even people here in Canada I deal with and work with, they've been doing it for 10 or 20 years, and they're still continuing learning and learning these little
Well,
tips and tricks, which is great.
like I said, the first one I did a startup on, it was, like I said, we used the industrial refrigerant. We were changing oil filters. We were changing oil. We wouldn't run for 4 hours, and then our oil filters would plug up, and we'd pump everything down and change them again and change them again. And then we were getting up to like where we could actually run for 12 hours. So we didn't have to come in at midnight anymore to change oil filters. And it gradually got to where we could run for a week without having to change oil filters. And I compare that to this, and again, we didn't do any nitro purging, and we were using dirty refrigerant and all this. Now it's like the filters were barely dark. We changed them as part of our startup, but they were nowhere near as bad as I've seen some filters on a, especially when you haven't done nitro purging. These filters were, they weren't plugged up by any means. There was definitely some stuff that they were holding back, but I've definitely seen worse. And again, it's what we know, right? Back wasn't even that long ago. It was just kind of like, it's CO2, just whatever, don't use nitro, and
Yeah.
get it down to 1,000 microns and you're probably good. And it's just we really, mentality changed, and it's all for the better. Again, it's all part of learning, right? How do you know? You got to do it a few times. Like I said, if you don't screw something up while you're at work, then you didn't actually learn anything that day, right? You gotta
Yeah.
make a mistake to figure it out, right?
I know for sure because I've done a lot of that over the years to learn and to get better and to grow. And this is what's great about CO2, continuing to learn, continuing to try stuff. Mistakes are going to happen, but if you learn from those mistakes, that's how you get better. That's how you grow. What are some of the, maybe let's talk about the top three things you got from this last previous job that you just did.
It really opened my eyes. Like I said, I was I'm really want the industry to catch up and start doing more CO2 installs, but there's that high installation cost that is really, and with these new package units, you've got these units that are not much bigger than a protocol or an IPAC, depending on your manufacturer, and they're running a half a grocery store. Like it's ridiculous. The footprint is so small. The installation costs have come down so, with these smaller units, and you're basically looking at similar or less costs than doing an HFC, and from now until forever, it's going to be cheaper to maintain and operate. So it really opened my eyes as the potential for these to start becoming quite prevalent, more than just in new installations, but in renovations as well. So that's really neat. And then, yeah, I can't wait to see, we're just scratching the surface here in North America. It's only going to get better. You can't start improving on something until you have it, right? Now that we have it and it's going to be more, then we can start improving on it. That's when it gets really exciting, right?
Yeah,
Yeah,
no, and I totally agree with that. I totally agree that we're going to see a lot more of this. A lot more of this is going to happen. CO2 in all different aspects, not only in the supermarket industry, but I see it in chillers already. See it in
mm-hmm.
heat pumps. We're gonna see full package system. I think it was about 2 or 3 years ago. I seen Daikin come out with a full solution. So it does your grocery store stuff, medium, low temp. It does your air conditioning. It does your heating. Just one system, and this is a convenient pack. And I've been talking with a few guys from Daikin about, and I'm learning more about it. I'm learning more about their swing compressor that they have. I'm learning more about having a package system, and we're going to see more and more of this happening, especially even on the supermarket side. Instead of having package units everywhere, you're going to have this one complete system. That's what we're working towards with CO2, because CO2 is such a great refrigerant, and we're going to continue to see it evolve, which really excites me because it's still new to us. It's still new to the industry. Refrigeration is not new, but CO2 is still quite new, and CO2 is not new either, but it's still quite new to the environments it's going in. So I'm super excited about all of that stuff.
Yeah, and it's about the schooling, right? Like when I was, say, 15, 20 years ago, CO2, we didn't even talk about it. And then it wasn't until CO2 finally started to show up and I was like looking into it, oh, this is great. And then you go back, oh, this has been around forever and we just stopped using it. And, again, installation costs and whatnot, it just, now that it's become feasible again. And again, just this most recent job, I just saw not only feasible, but economical too, from an installation standpoint. It rivals that of a multiplex rack installation, with these smaller package units. So it's become like I said, it's gonna take off like wildfire now. Now that it's within reach of more than just the big name grocery stores, right? Your Walmarts and your Sobeys and your Safeways. It's you can start getting into the range where smaller, non-franchise stores can actually afford CO2, and it would actually be starting to, be a better option for them moving forward, right? I wouldn't want to put any money down on which HFC or which refrigerant is going to be the next one to get phased out, or they're very expensive and complicated. When you get down to it, CO2 is simple, right? It's really easy. You don't have to worry about it. It doesn't separate. It doesn't, you're not worried about leaking part of a 400 series and not knowing what your charge is anymore. It's very simple. It's,
Yeah.
and it's just going to get easier and more readily available. So
yeah, and I love that too, because I really think the same along the same lines. Installations are going to get easier. We're going to get more knowledge out there, more continuing education. I see the schooling systems, at least here in Canada, they're starting to implement more CO2 into their training program. I'm talking to some good friends who are manufacturers who are trying to help implement that into the schools, you know. So we got to
Mhm.
work together as an industry to get this into the schools, get it into the different areas that we're going to see CO2. We're going to see it all over the country, which is really excited. I want to thank you so much, Nigel, for taking the time to chat about your experiences with CO2. Any final thoughts?
Oh, nothing's coming offhand, but no, it was great. Thanks for having the opportunity to, well, sit and chat
Awesome.
about this stuff forever anyway. So
Yeah, no, it's awesome. So if anybody has any questions, because we're here on a live session, throw them in the chat. I do have a question that came in. Installations with E2 with XM controllers. I'm having an issue with EEV valves bleeding voltage to the XM Modbus communication line and taking out communication port on the E2. Any resolution or discovery? Well, that's something you got to reach out to Emerson about, reach out to CPC, reach out to their electronics department. There's a friend of mine, Sean Gay, he's an expert on that. I'm sure he's talked about that. Reach out
I
to him.
think
Sorry, Sean. Reach
they
out
might
to,
have a resistor as well that you have to install when you're using an EEV. It
yeah,
probably bleeds that excess voltage.
maybe. Um, go on LinkedIn or Facebook and find Sean and ask him the question. He's such a great guy. He's an expert at all CPC stuff and E2 and E3. So just plug him, ask him that question. I got
Saw a
another.
question about the hotter climates. CO2 does work, but you usually have to get a little creative on your gas cooler side, adiabatic, or I've even seen some installations where they're using ammonia on the roof to chill, to keep the head pressure down, and where you can't use the ammonia in the store, but it's on the roof, so it's safe. And then you're getting two really efficient refrigerants working together. You know, it's just, you have to get creative when your climate is above that 88 degrees Fahrenheit, or on average is above that. Then, you know, you do have to get a bit creative. The
Yeah.
efficiency goes tanks when you're, you know, normally it's pretty good when you're in transcritical, you're refrigerating your refrigerant. So, you know, you're spending money on that, trying to do that. You're obviously going to see losses in efficiency, but yeah, if you can keep it in subcritical, it's amazingly efficient.
Yeah, definitely. Like I have friends in South Africa that have been running CO2 plants for over 10, 15 years. And they said the hottest it gets is like 42 Celsius and they're still purring like a kitten.
Mm.
So you just really need to understand the design for that question. And just like Nigel said, there's different applications. They're called warm ambient strategies. Could be adiabatic, like Nigel said. It could be parallel compression. It could be ejectors. It could be mechanical subcooling, probably like you're talking about on an ammonia side. So there's lots of different options. But once again, you want to work and understand the area or climate that you're working in because, for example, the adiabatic is not going to work in a wet climate.
Mm-hmm.
You know, that's the whole point of it. So, great question. That was a great question, and something you want to look into depending on the area. But if it's in a hot climate, it doesn't matter where it's at on the planet, you can use CO2 today, which is amazing. Nigel, I want to thank you so much again for taking the time to hang out with us and let us know your CO2 experience. We got one more question to pop up. We might as well take it. What is the difference between transcritical and subcritical CO2 systems?
Essentially, like I said, your transcritical, your higher pressure, your gas cooler is just that. It's rejecting heat, but you're not actually condensing your refrigerant, and that happens inside your receiver, your surge tank. At that point, when you're in subcritical, it's acting basically as a condenser. You've got high pressure vapor CO2 going in, and it begins to condense, and then you've got liquid and vapor coming back out.
Yeah, no, exactly. When you're above, like we talked about earlier, above 87.8 degrees Fahrenheit or 31 degrees Celsius, there's no pressure temperature relationship. And like Nigel said, that would be a gas cooler condenser. When you're below that, now you're in subcritical. It's just like a HFC system or a standard refrigerant or HFO system, whatever you want to call it. You're in that subcritical zone. So hopefully that answers your question. Once again, Nigel, thank you so much. Thanks, everyone. And I'll see you at the next CO2 Monday with Trevor. Have a great one.
Right on. Thanks, Robert.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button because When you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.